Hello students, welcome you to this session. In this video, I am going to teach you symmetric and asymptotes. Two important areas at the same time, very simple one. Symmetry, the curve is symmetric about x-axis. The meaning, suppose say here this is x-axis and y-axis. What you have here, the curve, same shape should be here. Then we say it is symmetric about x-axis. Y-axis, whatever you have here, same thing should be here also, right? So symmetric about x-axis, symmetric about y-axis, symmetric about the origin. So that means whatever you have in the first quadrant, suppose if we have something like this, so here, so it should be the other side also, here third quadrant also. Okay, so we say it is symmetric about the origin. So these are the three types of symmetry we are studying here. So mainly the definition you study. Then when you trace the curve, when you draw the curve, we look into the symmetry also, whether it is symmetric about x-axis or y-axis or the origin. Okay. So there are three types of symmetry. Suppose the given curve is a function of x and y. To check whether the curve is symmetric about x-axis, you change the sign of y. Change the sign of y. That is, f of no change in x, wherever y comes you put minus y. That only we are writing f of x comma minus y, meaning for x you write x itself, for y you write minus y. If you do so, when you do like this, there is no change, you are getting the original function itself. Then you say the curve is symmetric about x-axis. The curve is symmetric about x-axis. This is how we have to check whether the curve is symmetric about x-axis. How to check the curve is symmetric about y-axis? For x-axis, we change the sign of y, just opposite, right? To check symmetric about y-axis, you change the sign of x. So that is, you find f of, so to check symmetric about y-axis, you change the sign of x. Minus x comma y. No change in y. We are replacing x by minus x. But there is no change in the answer. Then you say the curve is symmetric about y-axis. And the third one, we have to check whether the curve is symmetric about the origin. For that, you change the sign of both. Change the sign of x and you change the sign of y. That is, you are finding f of minus x minus y. There is no change in the answer. Then you say the curve is symmetric about the origin. Okay. So suppose if we have a question like this, say y square equal to 4ax. Listen, is it symmetric about x-axis? It is a function of x and y, right? So here, when you change the sign of x, it will affect, it will become minus 4x, right? But when you change the sign of y, minus y the whole square. What is minus y the whole square? Y square itself, no change. So when you replace y by minus y, there is no change. So we say the curve is symmetric about x-axis. The curve is symmetric about x-axis. That is why we are getting a curve like this. So here we have some portion, same thing here you have here also, it's a parabola, right? Already you studied. So like this you can check for what? Symmetry, okay? So the next one is asymptotes. So asymptote means it is a line very close to the curve but it never touches. So such lines we call it as asymptotes. For example, see, suppose you have a curve like this. Suppose you have a curve like this, okay? It's moving like this. And there is a line. There is a line very close to the curve. The curve is moving like this. Okay, the curve is very close to the line, but it never touches. Okay, very close to that. And that line we call it as what? Asymptote. Asymptote is a line. Okay, it's very close to the curve, but it never touches. So looks like a tangent, right? But tangent means it touches at one point. It touches at only at infinity. Okay, so it never touches. Such line we call it as asymptote. Not only like that, later in probability we study. This curve is called normal curve. This line very close to the normal curve. So this baseline, that is the asymptote to that normal curve. Okay, so asymptote means it is a line. Here we are going to study three types of asymptotes: horizontal asymptote, vertical asymptote, and slant asymptote, and we have a lot of questions based on that. Okay, so that we are going to study in detail in this video. Okay, listen. The definition of asymptote: an asymptote for the curve y equal to f of x is a straight line. It is a straight line which is a tangent at infinity. That means it touches only at infinity, right, to the curve. There are three types of asymptotes. One is horizontal asymptote, second one vertical asymptote, and the third one slant asymptote. So we are going to study in detail the theory part. After that we do the sums. Horizontal asymptote. So how can you find the horizontal asymptote? So horizontal asymptote means, horizontal, it is parallel to x-axis, right? So they can ask for short note also. It is parallel to x-axis. So here, that is y equal to k is a horizontal asymptote of the function y equal to f of x if there is a condition. What is the condition? Listen. Limit x tends to infinity. Limit x tends to infinity or limit x tends to minus infinity. F of x, you have to get the limit. You have to get some number, okay? Or instead of x tends to infinity, you can give what? Limit x tends to minus infinity. Limit x tends to minus infinity. F of x equal to some constant or some L, okay? So limit you give x tends to infinity or x tends to minus infinity, the limit exists. That is, you are getting a fixed number. Then we say there is what? Y equal to k. Y equal to k is a horizontal asymptote. Horizontal asymptote. So horizontal asymptote means it is parallel to x-axis. Parallel to x-axis means it is y equal to constant, right? Here the constant is k. Y equal to constant, the constant is what? K. So y equal to k is said to be the horizontal asymptote. Y equal to k is the horizontal asymptote if limit x tends to infinity f of x equal to k. Limit x tends to infinity or limit x tends to minus infinity. In any one of the case, the answer must be k. Then you can say y equal to k is the horizontal asymptote. Now the next one is vertical asymptote. So vertical asymptote, it is parallel to y-axis, right? Vertical asymptote, it is parallel to y-axis. So the first step you write, it is parallel to y-axis. And here, that is x equal to a, parallel to y-axis, right? Parallel to y-axis means y equal to constant. Y-axis equation, x equal to 0. Y-axis parallel means x equal to constant, right? X equal to a is a vertical asymptote. If vertical asymptote of the curve y equal to f of x, if there is a condition. What is the condition here? Limit x tends to a plus. Right limit or even left limit. Limit x tends to a plus or limit x tends to a minus of f of x equal to, you have to get either plus infinity or minus infinity. Or limit x tends to a minus f of x equal to plus or minus infinity, right? Plus or minus infinity. So this is the condition for vertical asymptote. And the last one, that is called slant asymptote, or another name is oblique asymptote, okay? So here, slant asymptote, I'll tell you how to find that, but you must know when it occurs. So it occurs, they give one expression, right? A function of x. So numerator, denominator. You see the degree of numerator and see the degree of denominator. If the degree of numerator is greater than the degree of denominator, there exists a slant asymptote, okay? It occurs when the degree of the numerator is greater than the degree of the denominator. Then how to find this slant asymptote? Very simple. Numerator degree is greater, right? So write the numerator inside and divide by the denominator. You get some remainder. Don't worry about the remainder. You will get a quotient, right? You put y equal to the quotient. That is the slant asymptote, okay? Y equal to the quotient. Okay, so here the procedure is divide the numerator by denominator. So then y equal to the quotient, that is the answer you are right, is slant asymptote. Don't worry about the remainder. Whatever remainder you get, just leave it. So you take the quotient, equate with y equal to that quotient. That may be a function of x, right? That is called slant asymptote. So these are the three asymptote. Asymptote means it is a line very close to the curve. It touches only at infinity, or you say it is a tangent at infinity, okay? So there are three types of asymptotes. First one is horizontal asymptote. Horizontal asymptote means parallel to x-axis, so y equal to constant. Y equal to k is said to be a horizontal asymptote. If limit x tends to infinity or limit x tends to minus infinity, f of x equal to k, then y equal to k is called horizontal asymptote. Vertical asymptote, parallel to y-axis. Parallel to y-axis means x equal to some constant. X equal to a is said to be a vertical asymptote. X equal to a is said to be a vertical asymptote if limit x tends to a plus or limit x tends to a minus, f of x, your answer should be infinity, either plus infinity or minus infinity. Then it is called what? Vertical asymptote. And the third one is slant asymptote or oblique asymptote. It occurs when the degree of the numerator is greater than degree of the denominator. Here the method is very simple, long division method. So numerator you divide by the denominator, you get some quotient and remainder. Leave the remainder, equate the quotient with y, and that is the slant asymptote. Okay. Now based on that we try few questions. Exercise 7.9. There are two types of question. First type question, finding the asymptote. Second one, draw the graph. But this is the basic thing. Asymptote, if you know, you can trace the curve also. Okay. Look at the first question. Find the asymptotes of the following curves. Y equal to f of x. X square by x square minus 1. So the given function is f of x equal to x square by x square minus 1. Please listen here. Very easily you can understand. See the denominator. What is the denominator? X square minus 1. When the denominator is 0, something by 0, the value is what? Infinity, right? So when the denominator becomes 0, x is equal to x square equal to 1. So x equal to plus 1 and x equal to minus 1, right? So when x is equal to 1, you take the limit. Your answer is infinity, right? When x is equal to minus 1, you take the limit. Again, your answer is infinity. So, both x equal to 1 and x equal to minus 1. X equal to constant. Please listen. X equal to constant. That is the vertical asymptote, right? X equal to 1 and x equal to minus 1. So, there are two vertical asymptotes. X equal to 1 and x equal to minus 1. What about horizontal asymptote? You have to take the limit x tends to infinity, you take, right? Suppose you take limit x tends to infinity. See what you get when you apply the limit. Limit x tends to infinity. Numerator x square. Denominator take x square common. Even though it is not common, take outside. You will get 1 minus 1 by x square, right? Infinity you give 1 by infinity, right? 1 by infinity is what? 0, right? So what you are getting here now? When I take infinity, so 1 minus 0, right? 1 by 1, so the answer is 1. So you are getting 1. So you can say y equal to 1 is called what? Horizontal asymptote. Y equal to 1. Y axis 1. So this is the horizontal asymptote parallel to x axis, right? And these two are vertical asymptotes, x equal to 1 and x equal to minus 1. Slant asymptote won't be there because when the slant asymptote occurs, degree of the numerator must be greater, but here it is equal, right? X square numerator, denominator, degree 2 in both the cases, so there is no slant asymptote, okay? So please listen how to write the steps. I'll explain to you. Listen here. See, first the function is x square by x square minus 1, right? F of x equal to x square by x square minus 1. See the working rule. So how do you know whether you put x equal to 1 and x equal to minus 1? Equate the denominator with 0. So you put x square minus 1 equals 0. So x square equal to 1. So x equal to root 1 plus or minus 1. So these are the two vertical asymptotes you are going to get. But you write the steps. When you apply the limit, you have to prove you are getting infinity, right? So x tends to 1. Limit x tends to 1 f of x you are finding. For x you put 1. Numerator is 1 square 1. Denominator is 1 square 1 minus 1 0. Something by 0 is infinity. Okay, so x equal to 1 is one vertical asymptote. Second value, x equal to minus 1, you substitute, apply the limit, limit x tends to minus 1 f of x. There also you are getting infinity. So these are the two vertical asymptotes. To find horizontal asymptote, limit x tends to infinity you give, right? Limit x tends to infinity f of x you find out. Whenever x tends to infinity comes, you would have studied in the lower 11th standard, highest power you take outside. Numerator x square. Denominator highest power is x square. Whether it is common or not, take outside x square. Then it become 1 minus 1 by x square. Both this x square term get cancelled. When you put infinity, 1 by infinity is 0, so denominator is 1, numerator is 1, so 1 by 1 the answer is 1, right? So answer you are getting 1, that y equal to 1 is horizontal asymptote. So this curve has vertical asymptote and horizontal asymptotes. Now let's move on to the next question. Listen. Find the asymptotes of the following curve. You can check the third one very easily. Slant asymptote or oblique asymptote is there or not. For that you see the degree of numerator. Here what is the degree of the numerator? 2. Degree of the denominator is 1. So yes, degree of the numerator is greater than degree of the denominator. So there is a slant asymptote. Okay, that we are fine, that will do that. Okay, but before that we look into whether there is any vertical asymptote. For that you put denominator 0. You put, if there is no denominator, there is no vertical asymptote, right? Here denominator is x plus 1. When this x plus 1 becomes 0, x equal to minus 1, right? So when x equal to minus 1, so that is limit x tends to minus 1, f of x you find out. Check whether you are getting infinity. So limit x tends to minus 1, x square by x plus 1. So for x you put minus 1, so minus 1 square. Minus 1 square is 1. By minus 1 plus 1, 0. 1 by 0 is infinity. So x equal to minus 1 is a vertical asymptote. Okay. For horizontal asymptote, you put x tends to infinity, right? So then numerator x square, denominator it won't exist. You will get infinity only in this case. So there is no horizontal asymptote. Slant asymptote is there. Why, you know? Because degree of the numerator x square, denominator 2, denominator degree 1, right? So degree of the numerator is greater than degree of denominator, right? So there is a slant asymptote. So you divide it. Numerator is x square, denominator is x plus 1. So x square by x, it is x. By that x you multiply x into x square plus x into 1 is x. So subtract it, cancel, this become minus x, right? We change the sign. Minus x divided by x is minus 1. So minus 1, you multiply minus 1 into x, minus x. Minus 1 into 1, it is minus 1. You subtract again, change the sign. This become plus and this become plus. So you are getting 1 as a remainder. So you don't take the remainder. The quotient equate with y. So you can say y equal to the quotient. What's the quotient here? X minus 1 is slant, is the slant asymptote. Okay, slant asymptote, you have to find like this. Now let's move on to the next question. Listen, the third one. Find the asymptotes of the following curves. So here, when the denominator becomes 0, x square plus 2, x square plus 2. So there is no chance of making that a 0, right? So now then, limit x tends to infinity, give limit x tends to infinity of f of x. That is limit x tends to infinity of f of x. What is that? 3x by root of x square plus 2. So whenever infinity comes, you take the highest power outside, right? Numerator 3x, denominator root of, take x square outside, 1 plus 2 by x square, right? So that is limit extends to infinity, 3x by what do you get here? Root of x square means x into root of 1 plus 2 by x square. Cancel that x. You give infinity now, 2 by infinity. 2 by infinity means 0, right? 2 by infinity 0. Root of 1, it is 1 only. So 3 by 1, your answer is 3, right? So y equal to 3 is a horizontal asymptote. So y equal to 3 is the horizontal asymptote. There is no vertical asymptote here. Also there is no slant asymptote. Okay, so now let's move on to the next question. See the fourth one. Find the asymptote of the following curves. Very easily you can identify. Denominator you can make 0 when you put x equal to minus 3. It is 0, right? So x equal to minus 3 is a vertical asymptote you will get. Also slant asymptote will be there, right? Because numerator degree 2, denominator degree 1. So you have to divide and equate the quotient with y. That is a slant asymptote. So that also you can find here, right? So now we write the steps. So when limit extends to minus 3. How do you know? Denominator is x plus 3. Equate with 0. X plus 3 0. X equal to minus 3. That's why. X square minus 6x minus 1 by x plus 3. So here you are getting, whenever you give minus 3, wherever x comes you put minus 3 square 9, minus 6 into minus 3 plus 18, minus 1 by 0. So something by 0 is what? Infinity. So you can say x equal to minus 3 is the vertical asymptote. Then if you give limit extends to infinity, you will get infinity as your answer. So there is no horizontal asymptote. Next, for slant asymptote, here degree of the numerator is greater than degree of denominator. So there is a slant asymptote. So you divide it. So numerator is x square minus 6x plus 1 divided by x plus 3. X plus 3. X square by x is x. By that x you multiply both, x square plus 3x. So change the sign, minus. So cancel this minus. So minus 9x minus 1, right? I think it is minus 1. So minus 9x minus 1. So now minus 9x divided by x is minus 9. Multiply by that minus 9 here, minus 9x. Minus 9 3s are 27. Change the sign plus and this become plus. 9x cancel. 1 plus 27 is 26. So don't worry about the denominator. The quotient x plus 9 equate with y, and that is the slant asymptote. Therefore, slant asymptote is y equal to the quotient. What is the quotient? X minus 9. Okay. Now let's move on to another question. F of x equal to x square plus 6x minus 4 by 3x minus 6, right? By seeing the denominator, 3x minus 6 equate with 0. So 3x is equal to 6. X is equal to 6 by 3. X equal to 2. This is the vertical asymptote, but you prove it. Okay. For that, limit extends to 2 f of x. Limit extends to 2. Write f of x, the function. Wherever x comes, you put 2. Numerator, you are getting a number which is not equal to 0. Denominator 0. Something by 0, it is infinity. So x equal to 2 is a vertical asymptote. There won't be any horizontal asymptote. Now degree of the numerator 2, degree of the denominator is 1. So there is a slant asymptote. So you have to divide it. So x square plus 6x minus 4. We have to divide by what? 3x minus 6. But please listen, in the denominator, 3 is common, x minus 2. So what I am going to do, divide this by x minus 2 alone. Later the quotient you divide again by what? 3. That we do at the last. Okay. So first I am going to divide x square plus 6x minus 4 by only that x minus 2. So x square divided by x is x. So multiply with here x into x square minus 2x. Change the sign. This minus, so cancel. This become plus. So 6x plus 2x is 8x minus 4. 8x divided by x is 8. By that 8 you multiply 8x minus 8 2s are 16. You change the sign. This is minus and this become plus. So you will get 12. The remainder you leave it. But remember, the quotient you have to divide again by this 3. So actually the quotient is x plus 8 by 3. By that 3 we didn't divide, right? So split it, x by 3 plus 8 by 3. So this is the quotient. So the slant asymptote is y equal to the quotient x by 3 plus 8 by 3, right? So y equal to x by 3 plus 8 by 3 is the slant quotient. If you want, you can take LCM. You can do that. Okay. So hope you understood. So like this, you can find the asymptote. So asymptote is just a line very close to the curve. It touches only at infinity, or it is a tangent at infinity. There are 3 types of asymptotes: horizontal asymptote, vertical asymptote, and slant asymptote. Practice these questions. We'll continue in the next class.